So, in this lecture, we'll just sum up what we did in the last lecture, and then from there we will continue. So, if we see till now, what we have seen is that we have mostly talked about the structural, talked about the concept of neural network in a structural sense. Okay, what do we mean by a structural sense here is that we have talked about it uh, about how the network is what are the parts of a neuron, what happens where in a neuron, how a neuron actually what actually happens and how it looks like. Okay, different parts of it and how they work. And the neural network, that is a biological neural network, if you see, is in fact characterized, or the defining characteristic of a biological network is in fact learning. Okay, so learning is an important concept which we wish to bring into the neural network. So up to now, if you see, whatever we have seen, whatever I have taught you is basically trying to show you the structural things of neural network. But the major or the most important part of neural network is what is we call as learning. So let's see what is, I will see what is learning in this class and how it is implemented through this particular kind of a neural network called ADALINE. So ADALINE means adaptive linear network. So it is a type of neural network which is called ADALINE. And as name suggests, this is having a linear neuron. And from this we'll see what also see what is the concept of learning actually is, or what we perceive as learning in human beings. So if you see this network, if here you have inputs, and this is again a single neuron network, single one neuron network. This is the output, and these are the weights of the network. Since there are 4 inputs, there are 4 weights. And for this, first let us see what do we mean by learning here. So if you talk about learning, what learning basically is in a human being. So one type of learning is, if you must have seen in your childhood that if you are given a particular input or particular kind of ask for particular thing, and you just have to tell answer to it. That means the learning tables, if you remember, you go on just memorizing it again and again. So you take input, how much is this and what is the output. So if somebody asks this much, this table, then this should be the output. So that is how you have one concept of learning is. So here if you see, that is what we are trying to implement in this ADALINE. This is what is this network trying to do. So through this question we will try to see what learning is. So if you see, if I have x1 equal to this, having values 1, 2, 3, I input, if the input values of 1, 2, 3 are provided to a network. This is -1, which I'll call a bias input, because this input is same throughout all the inputs we are going to provide. So for a particular instant, if I provide this value of x1 as 1, 2, 3 and bias as -1, then my network should give me this result. When I provide this values to the network with a bias of -1, same, this bias value always remains same. And similarly this one. So when I provide this, I should get this as output, and network should respond this as output, and network should respond this as output for the respective inputs. So when a network is capable of doing this, then I say that my network has learned this concept, that if it is given with the input of 1, 2 and 3, it gives me a value of t1 equal to 1.4. If it is given a value of 9 to 4, then it gives me a value of output as 2.5, and so on. And that is one way of defining learning in this particular network. Now, how this network actually will do this? So basically, here if you see, the catch is in the weights. Okay, so the ADALINE weights are to be adjusted in such a way, that is what learning basically means here in a mathematical sense, that the ADALINE net weights are to be adjusted in such a way that when x1 is presented, you get d1 as output. When x2 is presented, then it gives d2 as output, and so on. So that is how uh, the learning happens. So if this ADALINE weights are adjusted and it starts giving these values what is desired for x1, x2 and x3, then we say that the network has learned. So basically, learning in a network boils down to how the weights are adjusted. So now I have just made a different what you can perception of this ADALINE network, where you see that now again same one neuron is there having four, sorry, here I think only three inputs were there, three inputs plus one bias input. So it is more generalized diagram here, but idea is same. So these are the inputs, and then you have the bias input, and I am now exclusively showing you the weights. That means these weights are there, and basically I have to adjust the weights in such a way that I get the output whatever is desired. Okay, so now my network should be like this. So for this network to learn or to have these weights so that it gives me the desired output, I need to have a mechanism of a, or a algorithm which will do that. That means by seeing the inputs, okay, x1, x2 and x3, by seeing the inputs, that means network was not pre-designed, it is some network. When I present x1, I should get d1, I should get d2, and I should get d3 whenever I present x1 and x2 and x3. So for that I should have an algorithm that when network sees this, it trains, that is what we call training. It trains itself by seeing this x1, x2 and x3, and along with that d1, d2, d3 is provided. The network trains itself so that the weights are adjusted in such a way that now when you don't have x1, d1, you don't provide d1 anymore, you provide x1 to the network, and network gives me output as d1, and that is how the network has learned. So let us see what is the idea behind it. So we'll see how this adaptive algorithm is, what this algorithm is actually. Of course, I'm not going into the proof of that algorithm as of now, but later in later classes we'll do it, just for taking the concept of learning into perspective. I have done this adaptive algorithm here without proof, but while proving we'll see why it works. So here what we'll do is, what the algorithm says is that you start with random weights. So W1, W2, W3 and W4 are randomly initiated. Some random values you can initiate. Now what it says is you present input x1 and get the output O1, and then you find the error between them, that is E1. Okay, so I'll just see if we can, oh sorry, by mistake I have put it there. I'll just come back here. Sorry for that. I'll just come back to that point. Okay, so these are the four inputs. First I'll initiate it by randomly. Then I present d1 to it, and x1 to it, and then I get the network output because of this random omega1, w1, w2 and w3. I get some O1, okay, output here. That output won't obviously match with D1. That output won't obviously match with D1, but that is what the error is. So I calculate the error for that. So once that error is calculated, I call it as E1. Then I calculate a value called delta W. Obviously it means increment in weights or change in weight is a function of or a product of E1, which is this error itself, which I have just calculated, the input which I have provided, and eta is a learning constant. You can have a very small value for it, say 0.1 or something like that, and this multiplication will give me a value of delta W, and my weights will be now updated. So my new weight, that is WK plus 1, is now the old weight plus the delta W, which is from here. So that is how I update my weight. Now in the second instant, now I provide, after calculating or after updating the weight, I provide x2, then I obviously get some O2, which is obviously not same as D2, and that is error I calculate E2, and based on that error I again calculate a new delta W and update this weight again, okay, WK plus 1, and I continue this correction for 3, and once all the 3 are over, obviously you won't get the same thing, I repeat it. So this is what you call training process. That means you go on supplying inputs, then you get output, then you compare that with the desired output, and from that desired output you calculate delta W and update this delta W, update the W with help of this delta W, and this process continues till I am able to find a set of weights which starts giving me the value of desired values for the inputs. So that is what the concept of training is. Now the issue is, whatever I have just told, will it work or not? That is, we have to write a program and implement this algorithm and see for ourselves that this works or not. Okay, so for now I'll stop it here and we'll see